Okay, so we have problem number 2 for the phase relationship of the soil. So we have a soil sample obtained through a hand-operated tool is a saturated clay that has a volume of 100 cubic centimeter and weighs 175 grams. If the oven dry weight is to be 120 grams, letter A, compute the volume of voids. Letter B, compute the void ratio. And letter C, compute the specific gravity of the soil. Okay, let's try to solve the problem number 2. So we're going to jot down first the given from the problem. So we have a soil sample to a hand operated tool is a saturated clay. So the volume given is 100 cubic centimeter. And then it has a weight that is 175 grams. And then it has an oven dry weight that is, so the oven dry weight is denoted as the weight of the soil that is, or dry soil, that is equivalent to 120 grams. So we're going to compute for the required. So we have letter A, we have compute the volume of the voids. Okay, the volume of the voids. So as we can see, for the volume of voids, that is equivalent to the volume of water plus the volume of air. Okay, or from the total volume, we have total volume that is equivalent to this one, that is the volume of voids plus the volume of the solid. So we have also the equation, the basic equation for the phase relationship of the soil, that is in relation also to our given. We have the weight of the soil that is equivalent to the weight of the water plus the weight of the solid. So to compute for the volume of voids, since our focus is the volume of voids, we can only get this equation. So we have volume of voids equals volume of water, since the air is considered to be 0. So we have here volume of voids equals to volume of water. So we're going to try to solve for the weight, in relation to weight, to solve for the volume of voids. So we have volume of voids equals to volume of water. So we have the weight, we have weight that is equivalent to weight of water plus weight of solid. So we have the value for the weight, this total weight, that is 175 grams, and we have the weight of the solid. So what is unknown here is the weight of the water. So we have weight of the water, or the total weight, minus the weight of the solid. So we have weight of the water is equals to 175 minus 120. So that is equivalent to, the weight of water is 55 grams. Okay, and then continue here. So we have volume of water, we have weight of water, so that is also considered to be the for the equation of unit weight of the water, that is equivalent to weight of the water over volume of water. So to solve for the volume of water, which is equivalent to the volume of voids, so that is the volume of water equals to the weight of the water times the unit weight of the water. So the unit weight of the water in terms of grams per cubic centimeter is equivalent to 1. So we have volume of water that is equals to our weight of water, that is 55 grams, multiplied by 1, that is grams per cubic centimeter. So the volume of the water becomes 55 cubic centimeter. Okay, let's move to the second required requirement for the problem. So we have the void ratio E. For the void ratio E, a while ago we have already calculations such as the volume of water that is also equivalent to volume of voids that is equivalent to 55 cubic centimeter. Now we have also another one. We have also the weight of the water that is equivalent to 55 grams. So we're going to go back to the equation for the total volume, that is V equals to volume of voids plus volume of solids. In here we have already the total volume and then we have volume of voids. Let's solve for the volume of solid. We can use this equation for the basic equation for the E. So we have Vs is equals to V minus volume of voids. So we have from the given, this is Vs by the way. So we have Vs equals to, we have V that is 100 minus the volume of voids that is 55. So we have volume of solids that is equivalent to 45 cubic centimeter or cc. Then let's try to solve for the E. The equation for the E is equivalent to volume of voids over volume of solids. So we have already volume of voids and we have already volume of solids. So we have E is equals to the volume of voids, that is 55, all over to the volume of solids, that is 45. So let's solve. This becomes 1.22. So our void ratio is 1.22. Next, let's try to solve the letter C. Compute the specific gravity of the soil. So we have specific gravity, that is Gs, G sub S. So in this equation, let's go back to the problem. The problem, the condition of the soil there, the soil sample there is a clay, and the condition there is saturated. That's why we have, a while ago, we have the volume of voids is equals to volume of water plus volume of air. That's why it becomes 0. It's because the soil condition is saturated. So for this case, we're going to see the equation, that is S for the degree of saturation, that is in relation to the moisture content plus the specific gravity plus the void ratio. So that is equivalent to the moisture content times the specific gravity all over the void ratio E. So in this case, since the soil is saturated, so our S is equals to 1 or 100%. So we have our S is 1, that is equals to moisture content plus multiplied by GS over 1 over E. Sorry. So this one, this has the equation E equals to the moisture content GS. But we are going to solve for the specific gravity. So this becomes GS equals to the void ratio E over the moisture content. Wherein our moisture content, since our given is more on the weights and the volume, so we have that is equivalent to the weight of the water over weight of the solids. So we can compute this one first and then substitute to the problem, or we can create another equation from this one in relation to that equation. So we have GS equals to E over weight of the water over weight of the solids. So we can have an equation also in relation to the void ratio and the weights, weight of the water and weight of the solid. So we have GS equals to E times the weight of the solid over the weight of the water. So this is another equation. But we can solve like this one now, in direct to this one. So we have the moisture content equals to the weight of the water over weight of the solid. So if in terms of percentage, in terms of percent, so you have to multiply this one with 100. So we have the weight of the water, that is 55 grams all over the weight of the solids. From the given, we have 120 grams. So calculating that one, multiplied by 100, so that is 45. Our moisture content is 45.83%. Okay, so that is for the moisture content. Now we can solve using this equation. So we have GS, to get the GS, so we have no, this one, you can use this one, or you can use any of this. So let's try this one. So we have the void ratio E. We have E. Our E here is 1.22 multiplied by 120 divided by 55. So our GS is 2.66. So that is the specific gravity. So that answers our problem number 2 questions.